Right, hi everyone, welcome to my YouTube channel City of Electrons, and in this video we are going to work on this. This is a sample. So we've talked a lot about the partial fraction equation. We've talked a lot about the differential equation, and in the last video we looked at the system as a network. Yeah, this network, and we derived the differential equation for it. So now in this video, let's assume that this differential equation represents a system. This differential equation represents a what? A system. So what we want to do now is to solve the differential equation, assuming we've gotten the differential equation from the system. Now take this is the differential equation. Now find the output of the system. Consider the differential equation. This differential equation. These are the terms. If you watch the previous video, you understand why we have y dot of 0 given. So we are given y dot of 0, we are given y of 0, we are given x of t. Okay? Of course, this is a unit step function, and the unit step function is what? 1 unit step. So we have to find the output, which is y of t, and this is what? Y dot of t. This y dot, this y dot, this is y of t. So what we are asked to do is to find this guy, right? So we are going to do that using what? Laplace transform. We are going to do that using Laplace transform, and we are also going to apply the partial fraction decomposition. So let's start. I'll show you the process step by step. Solution. Let's go. The first thing, this is the expression brought down here. Nothing, no difference. Okay. So the first thing, taking the Laplace transform of both sides. Now progressing. Okay. So how to take Laplace transform? We have also done that. So taking Laplace transform of both sides, when we take the Laplace transform of this, we are going to get this as the answer. Remember, we have 2 dots. You can see we have 2 dots. So, meaning s will be raised to the power of 2. The first one, you have y of s. Next, minus s will reduce. So you now have just s, no longer s squared, but s. Then you now start the y of 0 series. Y of 0 minus s will reduce. There will be no longer s, no s here again. Y will now have this first dot, y dot of 0. So we are done with this first guy. Next we go to this part. Okay, of course the 6 is a constant, so you bring it out. How many dots do we have here? 1. So the first s will just be here 1. Of course invisible 1. So y of s minus s will disappear, which is raised to the power 0, and that makes it disappear. Raised to the power 0 meaning that's 1. 1 times y, the same y. So y of 0. So we are done with that because there's no more s term. So we are done with that. Go to the next thing. 8 is a constant. No dots. So we just have what? Y of s. Same thing to this guy. Gives us this. Exactly what we explained. And same to this gives us this. Okay? So because there's 1 dot, so you have 1s, x of s, minus no more s. No more s, so you just have x of 0, plus the next thing, no s at all, so you just x of s. Okay, so what we do, of course, we remove the brackets, and you have these parts. So we just remove the brackets to give us these parts. Similarly, we just remove the brackets to give us this line. Remove the brackets to give us this line. So next thing, we gather all the terms that has s. Come here. Okay, this one has s here. What again? This one has s. Okay. Yeah. Just gather all the terms that has s. Yeah, that's s. S y of 0 is it? Okay. Sorry about that. What happens next is we substitute in the values. Y dot of 0 is 3. Y dot of 0, so we'll put 3 there, and that's what happens next. Okay, no other y dots, no other y dot. Y of 0 is 1. Where is it? Y of 0. Sorry, y of 0, this is 1. 1 times s, s is left. Are we seeing that? Then, which other term we will give you? X of t is what? Us of t. We've not gotten to this part because there is no x of t here. Okay, so let's keep solving. However, x of s is what? S of s is what? 1 by s. Why? Because the idea of unit step function. So the idea of unit step function, us of t, is that it's 1. And if you take the Laplace transform of a 1, what do you get? 1 over s, because 1 is a constant. So in place of x of s, we'll get 1 over s there. Same thing here, 1 over s. Okay? So what we did at this line was to substitute in the values. And then we'll take what's common. Things that have s. So things that have 1 of s, this guy has 1 of s. We bring it down here. What else? This one has y of s, we bring it down here. So that's y of s, we bring it down here. This one just s, we separate it. This one only 3, we separate it. This one only 6, we separate it. This guy will cancel this guy. All we have left is 1. 0 is out. Plus 1 by s, plus 1 by s. Are we following so far? So, with that being said, we can factor out y of s. So what will be left inside is what? S squared, 6s, 8. Okay? And then this guy crosses to the other side, becomes plus s. These two give us minus 9. Minus 9 cross to the other side, give you what? Plus 9. Okay? So we've gone far. Well done. Now, divide both sides by this guy so that we have the y of s alone. Divide both sides by this guy. This guy comes on that. First, let's bring these guys together. Okay? This guy should have done that step. These guys, bring them together. That will be what? This will multiply this to have a common LCM. This will multiply this. Okay? Just like saying s plus 1 all over s plus s plus 9. So this times, forget about this guy first. So this times this will give you s squared. Divisible, and this times will give you s squared. Then this times this, everything here will remain the same. This times this will give you s. So that will be s plus 1 plus s squared all over s. Then repeat that, then do that with 9. That will be what? All over divisible 1. This will multiply this. This will multiply this, will multiply everything here. So I'm just trying to give them common denominator, okay? So this will now be, when 1 multiply everything here, that will remain the same. So it will be s plus 1 plus s squared. Then when this s multiply, this will give you what? 9s. That will be plus 9s all over s. Okay? Good. Of course, this will come and add to this will give you 10s. Oh, I think we are arrived at this point now. So we can see that s, look at the s. This s, look at it s. This 1, look at it 1. S squared, look at it s squared. 9s, look at it 9s. Okay? Now where this guy, s squared plus 6s plus 6s plus 6s plus 8 is coming from this side. When we divide both sides by this, that's why this guy came under here. Hope that's clear. So y of s equals all this. What happened just now is that we say 9s plus s, that's 10s. S squared, look at it, 10s. And s squared, look at it, s squared. S plus 9 giving 10s plus this 1. So we have this like this. Beautiful. Now, we can express the denominator in roots. this expression now, it looks like the previous video we had something like this, where we now said to decompose this thing. This is a rational function, because a function that has something over something is rational function. So in order to reduce this to simpler sum of fraction for us to take the Laplace inverse, we now use partial fraction decomposition technique here. But first of all, we have to express the denominator in its roots, so that we can now say pole 1 this, pole 2 that, just like what we said in these parts. Yeah, just like what we said in these parts. Okay, so we want to express the denominator as roots. So looking at this guy already, this one is one root already. So we want to express what we have inside in terms of roots. So look at it. I just pick only the denominator now. Look at it. S, I leave it alone. What is inside S? We now say S squared plus 6S plus 8. We now look for, this is just basic factorization. That is, okay, basic factorization. That is, you say, okay, right here. Use this to multiply this. You will get 8S squared. You get what? 8S squared. Now, what will you multiply to give you 8S squared? And that same thing, add it to give you 6S. Okay? The simple technique is to do this. This will give you 4S squared. And give you 2S squared. This will give you 1S squared. Of course, S goes in, that will give you what? S go again, give you this. So it's from these values here you can get that number. 2 times 2, that's 4. So what's left is just 2. So we can take 4 times 2 times 2, 4 times 2, 8. Okay, then 2 plus 4 is what? 6. So we can use 4 and 2. Of course, SS. So in place of this 6S, we will now replace it with what? 4S and what? 2S. So S squared. Where we had 2S, we are replacing it with what? 4S and 2S. Because if you use 4S times 2S, you get what? 8S squared. 4S plus 2S, you get what? 6S. Makes sense. So now you separate, you factor out what? What's common here? S. Factor out S. If you remove S, what will be left? Remove S from here, what will be left? Just S. Remove S from here, what will be left? Just 4. So that's what we have here. You do the same thing to this. What's common? 2. Remove 2 from here, what will be left? S. Remove 2 from here, what will be left? 4. So since this is the same as this, you just take one part. S plus 2. Take one part. The same, these two are the same now. So you just take one part. S plus 4. What do you have inside? S plus 2. You take the S plus 2. This S outside, look at it here. So these are the 3 roots. Okay? So in place of this guy, we are going to write this guy, and it's still correct. Now we are going to take our partial fraction decomposition of this expression. So taking the partial fraction expansion, we are taking partial fraction expansion, which are going to use to decompose this rational function. So we are going to write this A, B, C. They are just constant or residue. You can use C1, C2, C3, whichever one. You can use A, B, C, whatever. So we have 3 roots, 1, 2, 3 roots. So we have 1, 2, 3 residues or constants. Now, S, one of the poles will be for this. Another one will be for the next one. Another one will be for the next one. Exactly. Now, S is equal to what? Is there any other number close to it? No, nothing at all. So S is equal to what? 0. So that's for A. So we've done an example on this before, so I'll just continue with it, and I hope you get what we are doing here. So A equals what? S y of s. This is the root now. Use the root. The idea is this: use the root of what you are looking for to multiply this term. Simple as that. Then ignore the rest. Are you seeing the simple trick? Ignore, if you are looking for A is equal to, what's the root? S. Use the root to multiply what? Y of s. What is y of s? All these guys. So this is the root. S, look at it, s. Y of s is what? All these guys. Put it here. This will cancel this. Okay? Now, we said s equal to 0, right? So anyway you see s, you put what? 0. Anyway you see s, you put what? 0. That will give you a equals 1 over 8. Let's go to the next one, b. To know what b is, you see s plus 4 multiplied by what? Everything here. Turn the rest into 0. So look at the b part now. B part, s plus 4 times y of s. S plus 4 multiplied by s. Now, s plus 4. S plus 4. Remember you are setting all of them to 0. Equal to 0. Remember the first one. We had only s, right? So we just say s equal to what? 0. But this second one now, we have s plus 4 equal to 0. Meaning s is what? Equal to what? S is equal to what? Minus 4. Because you move this 4 to the other side, minus 4. That's why we have it like this. Okay? So this s plus 4 will now cancel each other, s plus 4. So anyway you see s, you put what? Minus 4. So that's what we did here. S minus 4, S minus 4, S minus 4, S minus 4. And when you simplify that, you get what? B as minus 23 over 8. Similarly, for C is what? S plus 2. So that means C is what? S plus 2 equals 0. That means S equals what? Minus 2. Okay? So of course, use it to multiply Y of S. And y of s is all this. This will cancel this. Anyway you see s, you put what? Minus 2. Okay, and that's how we got c equals 15 over 4. Now, this fraction we have here, what is a? 1 over 8, you put it there. What is b? You put it there. What is c? Put it there. So y of s will now be equal to all these guys, if you just calculated. But select now. So let's go down. Thus y of s equals all this. Okay? And then you now see these guys will take, yeah, y of s equals this. Okay? Yeah, correct. I just remove this minus sign here so that here this plus will become minus. I just brought out the minus sign. Okay? So now when you take the Laplace, taking the inverse Laplace transform on both sides, this will become what? Y of t. This guy, you just bring this one down, and what? It's what? US of t. Okay? Plus, what do you have here? 15 over 4, come down, 15 over 4. This guy, you write it at what? Exponential. This is a plus sign, right? Turn this to minus 2t. Then US of t. Minus 23 over 8. You bring it down, 23 over 8. This guy, exponential. Exponential, what do you have here? Plus 4. So you have what? Minus 40 US of t. And that's your final answer. Okay? That's the final answer. Please, questions, comments, leave it in the comment section. And then, okay, pause the video, go over it again and again. And then I'll see you in the next video. Like, share, subscribe. Thanks for watching, and bye for now.